Newton, which is used in this formula for the law of conservation of mechanical energy. Then we may start with exercise number 1. Sub-question A. Steve exerts a steady force of magnitude 210 Newton on a stalled car in figure below as he pushes it a distance of 18 meters. The car also has a flat tire. So to make the car track straight, Steve must push it at an angle of 30 degrees. We are given the applied force, distance moved, and the angle at which the force is acting. And then we are asked to determine the work done. By definition, we know that the work is equal to the force, vector force, scalar vector displacement. And now the answer is here. We know that the force equals to the work equals to the force times distance times cosine of an angle between the force and the distance. Distance is given, the force is given, and an angle is given. Here you use only the numerical application of the formula 210 Newton times 18 meters times cosine over 30, which is equal to 3,273.6 joules. In number B, it is said that Steve applies a force given by its components and the unit vectors within a displacement also expressed in terms of components and unit vectors. From definition, the work done is equal to the scalar product of force and displacement. The definition of scalar product gives the x components are multiplied apart from y components. Then f scalar s equals fx sx plus fy sy. Here it's the reason why we take this is the x component of the force. Then this is the fx, and this is the fy, means the y component of the force, and this is the sx, means the x component of position, and this is the sy, means the y component of the vector position. Then it's the reason why we took 160 times 14 plus minus 40 times 11, which gives 1,800 joules in total. Because here we have Newton and meter, we know that 1 Newton meter is equal to 1 joule. Question number 2. A farmer hitches a tractor to a sled loaded with firewood and pulls it a distance of 20 meters along level ground, as shown in this diagram. And here to say a farmer hitches means a farmer connects. To hitch means to connect, to attach a tractor, this part, this front part, to a sled, this is back part, which is used to carry objects. Then here this sled is filled with firewood. The weight of the force of gravity of the firewood is 14,700 newtons, and the tractor applies a force to the load and the sled, and this force is a tension force because the sled and the truck are connected by a chain, and we know that the force in a chain is called tension force. Then the tension force equals 5,000 newtons, and this tension force is acting at an angle phi, which is equal to 36.9 degrees above x-axis. Then this tractor moves the sled with the firewood within a distance of 20 meters. Then along the way, as the road is not paved, means it is not smooth, the road applies a friction force of 3,500 newtons. And here we are asked to determine the work done by each force acting on the sled and the total work done by all forces. Here we have a detailed answer. Then we start with the work done by the tension force. This is the W with index T equals to the tension force times distance moved times the cosine of an angle between the tension force and the x-axis, which this is equal to 5,000 times 20 meter times cosine 36.9 degrees. This gives approximately 80 kilojoules. We continue to determine the work done by friction force is given by the friction force times distance times the cosine of 180 degrees. This is because between positive x-axis and the friction force there is an angle of 180 degrees, because we consider this front part, which the middle part, which is our sled. Then on the right side of the sled we have the position x. On the left hand side of the sled we have the negative x direction, which is where the force of friction is oriented. Then the positive direction is towards the positive x. Then the direction from positive x to where the friction force is oriented is an angle along a straight line, which is 180 degrees. Then it's the reason why here we take the work done by the friction force, which is equal to the friction force times distance moved times cosine of 180 degrees. This cosine of 180 degrees is equal to -1. And this work done by friction force is exactly minus 70 kilojoules. This negative sign comes from cosine of 180 degrees. Then the work done by force of gravity. We take the force of gravity times distance moved times cosine of 90 degrees. Why 90 degrees? It's because the force of gravity is along the y-axis, and the angle between y-axis and the x-axis is 90 degrees. This is a right angle. Then it's the reason why an angle between the force of gravity and the x-axis is 90 degrees. Then we know that cosine of 90 degrees is always equal to 0. Then 0 times any number gives 0. This is similar to the work done by a normal force. It is equal to the normal force times distance moved times cosine of 90 degrees. Why? It's because normal force is along the x-axis, is along the y-axis, and the y-axis makes an angle of 90 degrees with x-axis. There is a right angle between normal force and the x-axis, and the cosine of 90 degrees gives 0. 0 times any number gives 0. And we are done by determining the work by each force. And continue to determine the network. The network, which is the total work, is the algebraic sum of all works done on the body by each acting force. Then the network equals to the work done by tension force times the work done by friction force times the work done by force of gravity and the work done by normal force, which is equal to 80,000 joules minus 70,000 joules plus 0 joules, which is equal to 10,000 joules or 10 joules. There may be an additional question of asking the final velocity of the sled by considering that the sled started the motion with initial velocity, let us say 2 meters per second. Here, by using the kinematic equation, v squared minus v0 squared equals 2 times acceleration times x minus x0. This is the first relationship which is between the distance moved, acceleration, and the velocity. This formula cannot help us because the acceleration is a question mark for us. It's unknown. Since the acceleration is unknown, we can look at a second equation that can help us to determine the unknown. This equation comes from the work energy theorem. The work energy theorem stated that the net work done on a body is equal to the change in kinetic energy. Here, the change in kinetic energy involves the final velocity and the initial velocity of the moving body. Since the initial velocity is equal to meter per second and the net work is equal to 10 kilojoules, and the mass of the body may be calculated from the force of gravity, where the force of gravity equals mass times the acceleration due to gravity g, then the mass equals to the force of gravity times the acceleration due to gravity. The force of gravity was given to be 14,700 newtons. Then we divide by 9.8 meters per second squared, which gives 1,500 kilogram. Then we have the change in kinetic energy, 1 over 2 mv squared minus 1 over 2 mv0 squared equals to the net work done. Rearranging to get the final velocity, this 1 over 2 mv squared will remain on the left hand side, the net work and the initial kinetic energy on the right hand side, and then we get finally the final velocity equals to the square root of 2 times the net work plus mass times v0 squared over the mass. Then the net work is calculated in sub-question B. The mass of the body is calculated here to be 1,500 kilogram. Initial velocity is given to be 2 meters per second, and then we can replace each quantity by its value and obtain the final velocity to be 4.16 meters per second. And the homework. And then we may continue with further exercises. Exercise number 4. A person pulls on the spring in the figure below. The figure is here. In A, the spring is unstretched. Stretched displacement is equal to 0. B, the spring is stretched a distance x. And in C, the spring is compressed the same distance x. The force on the spring Fs and the applied force. Then we are given a person pulls on spring in figure below, stretching it 3 centimeters. This means that this stretched distance x is equal to 3 centimeters. X equals plus 3 centimeters in the case of stretching, and x equals to minus 3 centimeters in the case of compression, because they said in B, if instead the person compresses the spring 3 centimeters, compress means the distance is negative, but for the stretching the distance is positive, means x positive for stretching and x is negative for compression. Then the applied force is said to be 75 newtons. We are asked to determine the work done. How much work does the person do in case of stretching and in case of compression? We actually know that the work done in a spring, the work is equal to elastic potential energy, which is equal to 1/2 kx squared. Do we have k? No. Because we don't have k, there is a relationship between the applied force, Fp, that Fp, and the k. Fp equals to the spring constant k times the distance x, which is stretched, means stretched to the maximum. It's the reason why here we say that the spring constant k equals to the maximum applied force over the maximum stretched distance, equals 75 Newton over 0.03 meter, which is equal to 2.5 times 10 to the power 3 Newton per meter. And we need to apply this formula where this work done is equal to the elastic potential energy equals 1/2 kx squared equals 1/2 k is calculated here. This is the value of k, the same value of k, and x, this is the stretched distance x, which is equals to in the case of stretching. Then in the case of compression, the formula is the same and the answer will be the same because you have a minus. This is the stretched distance x. In the case of compression, it is the same, then it is squared. The minus a squared equals to plus a squared, and the work done is the same, is equal to 1.1 joule. Question number 5. A 145-gram baseball is thrown so that it acquires a speed of 25 meters per second. We are given a mass and the speed. Here you may understand kinetic energy. What is the kinetic energy? We know that the kinetic energy is equal to the product of the half of mass and the square of velocity. Here the mass is given in grams. It must be converted into kilograms before calculation. And check if the speed is in SI unit, which is meter per second. And then this is equal to 45 joules. And we are also asked to determine the network. The network is equal to the change in kinetic energy. Then equals final kinetic energy minus initial kinetic energy. Then this body starts moving from rest. If it starts from rest, to say the body starting from moving from rest means that the initial velocity of this body is equal to 0, which means that the initial kinetic energy of this body is equal to 0, because kinetic energy is equal to the product of the half of the mass and the square of velocity. Then here, if we consider initial kinetic energy, this is the initial velocity. Initial velocity is equal to 0. Then initial kinetic energy is equal to 0. It's the reason why we say that the network is equal to final kinetic energy equals to 45.3 joules. Then question number 6. How much network is required to accelerate a 1000 kilogram car from 20 meters per second to 30 meters per second? We are given the mass, we are given initial velocity and the final velocity. We are asked to find the network. Here, the initial velocity and the final velocity are related to initial and final kinetic energy. And we know that the change in kinetic energy of a body is equal to the net work done. And here the net work is equal to final kinetic energy minus initial kinetic energy. Means 1 over 2 mv2 squared minus 1 over 2 mv1 squared. The mass is the same. What changes is the velocity. Then this network is equal to 2.5 times 10 to the power 5 joules. And question number 7. A man cleaning a floor pulls a vacuum cleaner with a force of magnitude F at an angle 30 with the horizontal. Calculate the work done by the force on the vacuum cleaner, as the vacuum cleaner is displaced 3 meters. This question is similar to the previous questions. The work done by this force equals to the force times the distance moved times the cosine of an angle theta, which is between the force and the vector displacement. This is equal to 50 as the force 50 newtons times this is multiplication, distance moved, which is equal to 3 meters. Then we need to multiply by cosine of 30 degrees. And then at this level, every one of you may find the answer, which is in Newton meter, and you will change Newton meter in joules by taking 1 Newton meter to be equal to 1 joule. Then you may calculate this by yourselves. Here is the diagram. And here, this is the free body diagram showing all the forces acting on this body and the direction of the applied force. Question number 8. A 6 kilogram block initially at rest. To be initially at rest means the initial velocity is equal to 0. Is pulled to the right angle along along a horizontal axis frictionless surface by a constant horizontal force. Then we have this body, this block, which is pulled by this force in a direction of positive x-axis, because we have the positive x-axis and the positive y-axis. The body is moving to the positive x with a force acting on it oriented to the positive x. This means that theta, which is equal to an angle between the force and the x-axis, this angle is equal to 0 degrees. And from definition of the work done, this is equal to the force times the distance moved times the cosine of theta. When a force is acting in the same direction as the x-axis, the work done is equal to the force times the distance moved. Then find the speed of the block after it has moved 3 meters. It is said that this is the starting point. At the starting point, the initial velocity is equal to 0, because it is said that the body starts moving initially at rest. The initial velocity is equal to 0. Then this is the final position. We are asked to determine the final velocity at this position. Then, because we are in work energy, we need to use the work energy theorem in order to find an answer. The net work is equal to the force times distance. The force is given to be 12 Newton. The distance is given to be 3 meters. And we are given the initial speed. By using the work energy theorem, stating that the net work is equal to the kinetic energy final minus initial kinetic energy, then the net work equals 1 over 2 mvf squared minus 1 over 2 mvi squared. mvi squared. Then, since the initial velocity is equal to 0, by saying that the block was initially at rest, the net work is equal to the force times distance times cosine of 0. Cosine of 0 is equal to 1. Then Ft equals 1 over 2 Fd, which is equal to the net work 1 over 2 mvf squared. In this part, initial kinetic energy is equal to 0, because initial velocity is equal to 0. Then we may rearrange to find the final velocity. Then 2 may multiply both sides of equality by 2. 2Fd equals mvf squared. Then Vf equals square root of 2Fd over m. Then the final velocity is then 3.46 meters per second. Question 9 may also be solved in a similar way. As here we are given a 0.6 kilogram particle having a speed of 2 meters per second at initial position A, and a kinetic energy of 7.5 joules at final position B. We are asked to find kinetic energy at point A. This means initial kinetic energy equals to the half of the product of mass, the mass is given, square of the initial speed. Then we are also asked to find the speed at final position. We use the formula for kinetic energy. Because kinetic energy is given, mass is given, what is unknown is the final velocity. Then where the final velocity equals square root of 2 times the final kinetic energy over the mass. Then this by replacing the kinetic energy and the mass by their values, we get that the final velocity equals 5 meters per second, which is larger than the initial velocity. And then the network. The network is equal to the change in kinetic energy. Then final kinetic energy is given. Initial kinetic energy is calculated in sub-question A. Then we find the difference and get the network. Question 10 is also solved. We are given a 0.3 kilogram ball having a speed of 15 meters per second. What is its kinetic energy? Kinetic energy is equal to 1 over 2 times mass times the square of the speed. And this is initial kinetic energy and the initial velocity. And this is the first kinetic energy. Then if the speed is doubled, we are saying if the speed is doubled, what would be its kinetic energy? Means that if the second speed is a double means 2 times the initial speed. In what is the second kinetic energy? The second kinetic energy equals 1 over 2 times mass times the square of the second velocity. Since this second velocity is equal 2, the initial velocity times 2, we can replace the second velocity by this value, because 2 times v1 squared times 1 over 2 mass. Then the square of 2 gives 4. Then 4 over 2 mv1 squared equals 4 times 1 over 2 mv1 squared, where we know that this product 1 over 2 mv1 squared is equal to the first kinetic energy. Then we see that the second kinetic energy is equal to 4 times the first kinetic energy. By conclusion, if the speed is doubled, the kinetic energy is multiplied by 4, where we have final kinetic energy equals 135 joules, means 4 times 33.75 joules. The last question is question number 11 about power. We are given an elevator an elevator car has a mass of 1,000 kilograms, and this elevator is carrying people with a combined mass of 800 kilograms. As the elevator is a block which is moved either upward or downward by use of chains. Here we have a chains and a motor. Then here we have a chains which are connected to the motor. Then the force on the chain is called the tension force, and then this is the force which makes both the elevator, or means the lift, and the people to move up or down. Then a constant friction force retards its motion upward, means because this box is between the walls of a house. There is a friction between the walls of a house and the elevator. This friction force is downward because the body is actually moving upward. This means that the friction force is downward. Then we are asked to determine the power delivered if the speed is equal to 3 meters per second. This means that if we are given the forces and the speed, and we know that the power equals to the force times the speed. Here we need to know what is the force that is governing the motion of elevator and people. Here there is the force of gravity, always oriented vertically downward, where this capital mass is the mass of elevator plus the mass of people. And there is friction force which is oriented in a negative direction, means downward, because the elevator is in upward motion. And then the tension force always oriented towards the motor, upward. Then it's the reason why we need to find the tension. To find the tension, we need to apply here, means that this force is the tension T times the speed. So we need to find the tension. The tension is calculated by applying Newton's second law in a y direction. Then we have the sum of forces acting on the elevator is equal to the tension plus the force of gravity, and we have the friction force. We have these three forces. Now we are going to orient these forces or project these forces along a y-axis in the direction of motion. The elevator is moving upward, so the tension is positive. Friction force is negative. This is friction force, which is negative, minus the force of gravity, which is also negative because it is oriented downward. Then we have the tension force will be equal to the friction force plus the force of gravity. Then 4 times 10 to the power 3 Newton, which is the friction force, plus the total mass 1,800 kilograms, then times the force of gravity. And after determining the tension, you take the tension times the speed and you obtain the power delivered. In sub-question B, we are given that what power must be delivered when the speed is v in an upward acceleration. In this case, there is an acceleration. In first case, we equal the sum of forces by 0. If here we must equal to mass times the acceleration. In the first case, it is said that the speed is constant. To say that the speed is constant means that acceleration is equal to 0. But in the second case, acceleration is different from 0. Then it's the reason why the sum of forces must be equal to the mass times the acceleration. And here we have to, always the tension is positive, friction force is negative, and the force of gravity is negative. This is equal to the mass times acceleration. Then we have the new tension. After getting the new tension, we need to multiply by the velocity. If we consider that the velocity is 3 meters per second, if the velocity is 3 meters per second, then we will have the power delivered to be the power equals tension force times velocity equals 70,320 watts. And the work done by normal force, the work done by force of gravity, and the total work. You may consider the previous questions. So you need to do the question number 13 and submit it to me as well in a similar way used. Here is also another assignment that you have to do. You will do them in one paper and submit them as quick as